So going to go over page 7 now. And in page 7, we are looking to figure out valence electrons by using the electron configuration. At one point this semester, you were asked to write the electron configurations, both the orbital notation and the electron configuration notation, also the noble gas shortcut. But we really want you to focus in on being able to identify the number of valence electrons. So some things to think about here is that the number of valence electrons are located in the outermost energy level of an atom. So that's going to be the biggest. So that'll be like the biggest quantum, the biggest principal quantum number, which I don't know why I said that because we didn't really talk about that. So we're really talking about these numbers here, the big ones, the coefficients, the ones, the twos, and the big one, the big twos, the big threes, right? So the larger the number, the further away from the nucleus of the atom it is. So in this case, the valence shell, or the valence number of electrons, are these two right here. Or not valence electrons, it's the valence shell, the third energy level. So in the third energy level, I'm going to take the number of the number of electrons total. So I've got the 3s, and the 3p. So in the s and the p, there are 2 electrons plus 4 electrons, which gives me 6. So the total number of valence electrons present are 6 valence electrons. So I really took so going back one more step here, I guess I should probably dissect this a little bit more. So this number here, let me try to draw better. That number there is the energy level. This letter here, the P, the S, the D, as you're going to see, is the shape. And then the upper number, the uppercase, the superscript, that guy right there is number of electrons. Okay, so that's kind of dissecting the key or the code of the electron configuration. Now, moving forward, let's try the next one. So I have a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. The biggest energy level value is 4. So that tells me that that's the furthest away from the nucleus of the atom, and the number of electrons total in the fourth energy level there appears to simply be 2 valence electrons. In the next example, I have a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. So the biggest energy level is the 4s and the 4p, and that's important that we identify those together. So in that case there, the number of electrons that are total present would be 2 plus 2, so these 2, and so my number of valence electrons there is going to be 4 valence electrons. And then in the last one, it's a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 4d4. In this case here, my biggest energy level is the 5th energy level, and there happen to be a total of 2 electrons present, so my final answer here is going to be 2 valence electrons. Going along to ions and whatnot, cations have a positive charge because they lose electrons. Electrons are lost. Remember in my class we talked about cats being positive, cations. And then anions have a negative charge because electrons are gained. Now, so what that means is that if you see an atom that has a positive charge, not only is it an ion, it's going to be a cation. So Mg plus 2 is going to be a cation. And then Na plus 1 will also be a cation. P minus 3 has a negative charge, so it's going to be an anion. and S minus 2 is also has a negative charge. So that one's going to be an anion as well. Now, what you have to remember is that if it's positive, electrons are lost. So in the case of Mg plus 2, we would say lost because it's a positive charge. Na plus 1, also lost, positive charge. P3 minus, going to be gained, negative charge. S minus 2, also going to be gained, negative charge. Now, how we determine the number of electrons that were gained or lost is the number that is present in the superscript. So Mg plus 2 tells me that we have lost 2 electrons. Na plus 1 tells me we have lost 1 electron. P minus 3 tells me that atom has gained 3 electrons. And S minus 2 tells me that atom has gained 2 electrons. So, yeah. So I think that I'm going to stop this one right here, and I'll do a little bit more detail on the next page. So if you have any questions about how to identify valence electrons, or how to identify whether an atom is a cation or an anion, or how many electrons it's gained or lost, please have a chat with your teacher. Otherwise, good luck preparing for your exams.